but we have to think about what that data means. So let's take a look at some quick statistics. Because field data is different than lab data. When we get field data, or when we get lab data, we get a score. So our website was ranked 95 in a Lighthouse score. So we think, oh yeah, that's great. But if we take corresponding field data to that same score, we get lots of different scores. We get some people who had that 95. We had some people who had 100 and had a way better experience. But we also had some people who had a 64 and had a really crappy experience. And so we have to figure out, how do we interpret this data? What do we think that this means? Because 95 isn't the whole story. There's a wide range of experiences, and understanding what that means can change what you do. Now, when you look at that field data, we have to understand that we're taking a sample. Not all browsers will report this, especially Web Vitals, because the Web Vitals interfaces, the APIs in the browser that report this data, is only in Blink-based browsers today. Firefox hasn't implemented it. Safari hasn't implemented it. This is just in Chrome and Edge. It's the only people sending this data. Now, fortunately, there's a whole lot of people who use that. And so we still have a pretty significant sample size. But there's bias in that data that we need to be aware of. So for example, the red section of this is browser usage that I captured off of an Internet Stats website as of recently, 2020 aggregated. It might be a little different now, but for the purposes of our conversation, it's fine. So all of the red is Chrome, and the green, which is Edge, is now based on Blink, now that they moved over to it. And so we get data from them as well. Unfortunately, 14% of that Chrome section says it's Chrome, but it's Chrome on your iPhone, which isn't really Chrome. It's a Chrome wrapper around the Safari engine. And so it does not report Web Vitals because it doesn't have the API to do it. So the data here is going to be skewed. It's going to be biased. The data might have a positive bias on desktops because Chrome is going to represent a percentage of the users, but those users who use Chrome are probably, more modern machines. They probably keep them up to date a little bit better, and it's going to ignore all of the, old versions of Internet Explorer. It's going to ignore all the Firefox users. It's going to ignore the privacy, people who are privacy aware and use like Brave and Opera and those sort of things. We can also infer that it might have a negative bias on phones, because the data that we'll get from mobile devices is all going to be from Android. It's not going to be from iPhones at all. And Android devices tend to be quite a bit slower on web applications than iOS phones. And so mobile data is going to skew worse than the actual average experiences. And for Mac OS users, for MacBook Pros, that sort of thing, which have a pretty high adoption of Safari relative to Chrome. There's still a lot of Chrome, still majority Chrome, but there's a lot of Safari. We're not going to report that. We're going to underreport that percentage of users. So as you think about this data and interpret it to your own user base, you just have to think about these biases and pull them into your data. Another thing we should think about is, how do we roll up these numbers? So we have a whole bunch of different scores that come in from field data. And let's say we're going to be super simple about it, and we're just going to take the average. Well, the average kind of sucks a lot of the time, because here's an average of 80 based on these set of scores: 399s, 390s, 370s, and 360s. Well, 80 is right, but it's really half of my users have a totally unacceptable score. Here's another example, also 80. This is the majority of my users have a pretty great score, but I have two people who are just so bad that they drag the average down and make it seem like I'm not doing as well as I am. And so averages are very misleading. And so most of the time, field data is interpreted in percentiles. And what I mean by percentiles is median. So a median, half of your users will have a better score than the median, and half of your users will have a worse score. So the median in this case, or the 50th percentile, is 95. That's a very important number and it's interesting, but for Google's purposes, they usually care about the P75 number, which is 75% of your users have a better score than this. Google cares about that because it's saying, you know what, we're going to eliminate a big chunk of people who have like a really crappy experience on the internet, but most people will have this score or better. And so we're going to rank you based on that. From your own personal perspective, I think it's really interesting to care about P95. P95 basically gives you the idea of what your worst user sees. It's not actually your worst, but a lot of the time, your worst score from field data is going to be so hilariously bad you can't even imagine how it is possible. It's going to be from a bot in Outer Mongolia that runs on a 486 processor and has no idea how to load a modern web page at all. It is going to be so hilariously bad that you won't think it's real data. And so usually you have to lop off the worst 5% of users as erroneous data. And P95 is usually a common consideration for what your worst users would experience. So how would we interpret that? Let's look at some real data. This is a bunch of made-up data. Let's look at some real data. Here is some charts from real field data for real websites. And let's see, what does this tell us about it? So here's a chart, and it shows us how many users experience the site in each of these buckets. So, almost 2,000 people loaded a page in less than a second. A little fewer, and the median loaded it in less than 2 seconds. A little fewer left in less than 3 seconds, and that is our 75th percentile. So at this point, we've covered 75% of our users, 3 seconds or faster. Feels like a pretty fast site. But then the long tail comes out, and it slows down very gradually. And the 95th stretches all the way out to 7 seconds. And so we have a wide distribution for even sites that we feel are super fast. Here's another example from a real site. Now, this long tail stretches out really far, and it's not a perfect normal distribution. So the site itself is obviously slower. The median is at 4 or 5 seconds. The 75th is all the way up at 8 seconds. But somewhere up here, between 10 and 15 seconds, we seem to have more users have this worse experience than the ones around it. There's something about our site that makes this particular behavior, this particular performance, more likely than it should be. And so that'd be worth exploring more. And the 95th is obviously just terrible. Like, the worst users are seeing 20 seconds or more. Here's a hilariously bad site that almost has an inverse distribution, where it is really unlikely for people to have a good experience. Some people obviously do. These are probably people who work in the same building that your web server is in. But most people, the most frequent performance is 30 seconds or more, which is just a hilarious thing that you would never imagine happened. But this is real data captured from real websites through request metrics. So this data can take all kinds of different forms. So when you start measuring your own field data, you have to look at it thinking, I have a distribution of users. That distribution is biased based on where my data is coming from. And then what does that data tell me about my site and how it performs for different classes of users? Now, I know those are a bunch of abstract questions because they are. Like, every site is different. I can't tell you what your performance charts mean to you because every application stack is different. What your code does is different. Who your users are serving are different. And so I can't give you a here's how to make your site fast answer because that's going to be relative to you. But looking at your data can help you understand what your real user experience is.